This is The Science of GMOs. I'm Jessica Eise, and the question we're looking at today is, what are GMOs? And joining me to help answer that is Dr. Rick Meilan, who's a molecular tree physiologist here at Purdue University. Hi, Rick. How are you?
I'm well, thanks. How are you,
Thanks.
Jessica?
Thanks for joining me.
It's my pleasure. Thanks for inviting me.
Sure. So, first question is pretty simple. It's just, what does GMO stand for?
It stands for genetically modified organism.
Okay. So when you say organism, are you talking about just what we eat, or does that encompass other things as well?
An organism can be any living thing. It doesn't necessarily have to be something that we eat. So an organism can, for example, include a bacterium. And what a lot of people don't realize is that the drug companies in the United States use genetically modified bacteria for producing medicines to cure disease, as well as vaccines for preventing disease. And before the advent of this technology, these companies would extract pharmaceuticals from organs or from cadavers or from bodily fluids and use those to treat people. The problem is that oftentimes those extractives were contaminated and would result in the transfer of disease to the patients. So by using this technology, the genetically engineered bacteria are producing pure forms of the pharmaceuticals that don't contain the contaminants and therefore are safer.
Oh, that's great. And what, for instance, might be an example of a common medicine that we're all familiar with that comes from a GM source?
Insulin for treating diabetes. Before we had this technology available to us, the drug companies were extracting insulin from the pancreases of cattle and pigs that came from slaughterhouses. And those were, they were similar enough to human insulin that they could treat people, human patients with diabetes, using insulin derived from cattle and pigs. But scientists were able to identify the gene that encodes the product that makes human insulin. So they put the human insulin-producing gene inside of bacteria, and the bacteria produce the insulin and secrete it, and they can harvest this insulin and treat diabetic patients with human insulin. So it's again, it's an example of a pure form of a substance that is much more beneficial. In addition to producing medicines, genetically modified microorganisms can be used for producing vaccines as well. And an example of two vaccines that are produced in genetically modified organisms are one against cholera and the other against hepatitis B.
Okay, so GMOs, it's not just what we eat, it encompasses a wide array of things. But jumping back to what we eat, so crops, for instance, I know that people have been breeding different corn varieties for centuries or even millennium. Out in the fields, and what's the difference between that type of crop breeding and GMOs, for instance?
Traditionally crops have been genetically improved through conventional breeding, where they take two parents. One parent has some traits that the breeder is interested in, and another plant will have another collection of traits that they're interested in having in an individual. So the breeder will cross the two parents and select offspring that contain traits from both parents. And so through conventional breeding, you alter many traits simultaneously. So it's disadvantageous in that you have to do many rounds of what's called successive rounds of breeding and selection in order to produce an individual that contains all the traits that you're interested in having. So one of the advantages of genetic engineering is that we can alter an individual trait. We can take a gene that's responsible for a given trait and alter that individually without affecting any of the other properties of the plant.
So how prevalent are GMOs? Are they common? Where might we find them just in our daily lives?
Well, there are four main agronomic crops that there are many agronomic crops that have been genetically modified.
What are agronomic crops? Those just
things that are grown in agriculture.
Okay,
plants
all right.
that are
So
grown
just
for
corn,
human consumption.
soy.
Yeah, exactly. And corn
Okay.
and soybean are two examples of plants that have been genetically modified for various properties, including insect resistance and disease resistance and herbicide tolerance. But the four major agricultural crops that have been genetically modified are corn, soybeans, cotton, and canola. There are 3 countries in the world that produce about 90% of those 4 commodities. Those are the United States, Brazil, and Argentina. And about 90% of, as I say, 90% of those commodities are produced in those 3 countries, and over 90% of those plants are genetically engineered.
Okay.
So, for example, in the United States last year, 94% of the acreage that was planted to soybean had genetically modified soybean. 96% of the cotton that was planted in the United States last year was GM cotton, and 93% of the corn that was planted in the United States was GM. India is another country that produces or grows a lot of genetically modified plants, in particular cotton, what's called BT cotton, which is an insect resistant. And I think last year in India they planted 250,000 acres of BT cotton in India.
So it's really integrated into our life, particularly here in the United States.
And it isn't just these four agricultural crops, I mean, the four big ones, soybean and corn and cotton and canola. Apple, just last year, an apple variety that's genetically engineered was released, and it's called Arctic. I think it's called Arctic apple, and it's one that has reduced browning. When you cut open an apple and leave it on the counter, it turns brown. So now this thing has been engineered in a way so that it doesn't brown as easily, and they have some genetically modified potatoes that don't bruise as easily. Cassava is genetically modified for virus resistance and is grown in Hawaii. So GM plants are grown pretty widely throughout the world.
And are there any other ways in which GM technology could be used?
Oh yeah, a lot of people think that using GM technology we are only inserting genes, but actually using the same technology we can alter expression of native genes, the genes that are present in the plant. And so there's a fellow named Norman Borlaug who in the 60s bred a short-statured variety of wheat, and Norman Borlaug is credited as being the father of the Green Revolution. And he won the Nobel Peace Prize in 1970, and he's credited with having saved 1 billion people from starvation by developing this short-statured variety of wheat. But using modern molecular techniques, we figured out that the genes that he introduced through his breeding altered the expression of a hormone that influences the height growth of plants. It's called gibberellins. And so what we've done is we can genetically engineer the plant to either overexpress a certain product or to reduce the amount of a certain product that's produced. So in this case, we can alter the gene that's responsible for making the hormone that influences height growth, so we can accomplish the same thing that Norman Borlaug did through decades of breeding in a single year by just altering the expression of a single gene.
So why would we want short wheat?
There was particularly with rice, but it's not just a problem with rice, but with other cereals. But it was originally identified in rice. It was called foolish seedling disease.
Foolish
seedling disease. What happens is that we would breed rice plants to produce large panicles, a lot of grain, but they had long, narrow stalks, and the weight of the panicles, the seeds, the grain was so much because we bred them for producing an abundance of grains. The plants were so heavy, top heavy, that they would blow over, they would lodge or fall over,
they'd fall down.
and then they'd rot in the rice paddies. And so by producing a short-statured plant, the stems were shorter, but they were thicker, and they could support the heavy grains.
Great. Thank you so much, Rick, for joining us to help us understand what GMOs are. We really appreciate it.
My pleasure. Thanks for having me.